everyone, welcome back to the Complete DSA series, and today we are diving into a super fun and visual problem, valid parenthesis. It is one of the classic problems that look dead simple but secretly teach you the power of stacks. By the end of this video, you'll understand not just how to solve it, but why the stack fits perfectly for it. So let's get started. So now the question says you're given a string like and you have to answer one thing. Is this a valid parenthesis string or not? Valid means three very simple rules. Every opening bracket must be closed in the correct order and by the correct type. Means this, box bracket with box bracket, curl bracket with curl bracket. If you mess up with any of those, the string becomes invalid. Now let's make it super intuitive. Think of it like packing and unpacking boxes. You open a box, you must close the same box. You can't close your big outer box before finishing all the small boxes inside. So brackets are literally nested boxes. Like for example this one. This is valid because you can see the neat nesting. But this one, see how here the curl bracket, this is a odd number of strings. This is invalid because you tried to close the wrong box first. So how do we handle this programmatically? The secret weapon for this problem is stack. Why? Because stack follows the LIFO rule. That is last in, first out. Just like the last box you opened is the first box you'll close. So if you open brackets like this, you have to close them like this. This is the exactly how parentheses work. So stack is the perfect fit. Now here's the simple rule to live by. Whenever you see an opening bracket, we push it into the stack, and whenever we see closing bracket, it must match the top. If it doesn't match, the string becomes invalid. If stack becomes empty before finishing, the string becomes invalid. And if the stack still has stuff after finishing, it is invalid. That's it. Literally three checks. Now let's look at the example. Our first character in the string is the curly base opening. So we push it into the stack. Then we have a box bracket. Then we have parentheses. So that at here the top is this. So we pop the top element, and if the top is this, so we pop. Next, the top will be the box bracket, so we pop. And last, the top is curly bracket, so we pop. In the end, the stack is empty. When the stack is empty, that means our string is valid. Now let's look at the other example. See how here the top is a parenthesis and we are having a box bracket. The top is a mismatch, so the string becomes invalid. We stop right there, and the moment a mismatch happens, the string becomes invalid. Now let's look at the edge cases for this problem. Some quick tricks: always remember that an empty string is always a valid string. Only opening brackets, if only opening brackets are there in the string becomes invalid. If only closed brackets are there, the string becomes invalid. And the odd length string is automatically invalid. So let's look at the Java code for this problem. So we start by creating a stack, a character stack. Then we will push opening brackets into this stack and pop them while we encounter closing brackets. We loop through the string. We check one character at a time. And if it's an opening bracket, we push it. Why? Because we need to remember that this bracket is waiting to be closed. Think of it as opening a box and keeping it on the stack. Next, we check if it's a closing bracket. This line means that if we got something like this, but there is no opening bracket before it, we invalidate this string immediately. Example this. After then we get the last open bracket by the cat of equals stack.pop. We remove the last open bracket because we are trying to close it right now. We check if it matches the top correctly. So the rules: this string must match this string, a box bracket must match a box bracket, and a curly should match a curly brace. If it doesn't match, we return invalid. And after the loop, the stack must be empty. So we return stack dot is empty. Why? Because if stack is still has something, some opening bracket was never closed, so it becomes invalid. And if the string is empty, everything closed properly. So it becomes valid. One line explanation for this problem is use a stack, push opening brackets, pop for closing brackets and ensure correct matching. If the stack is empty at the end, it's valid. The one line intuition for this problem is that the stack remembers which bracket was opened last, and every closing bracket must perfectly match it. If you understand this, you have already mastered half of all stack problems. And that's it for today's session on valid parentheses. If you enjoyed this breakdown, drop a heart in the comments and tell me which stack problem I should cover next. Maybe main stack, next greater element, or daily temperatures? Just let me know. And don't forget to like, share, and subscribe. Keep learning, keep building. See you in the next video with more colorful DSA on the whiteboard.